All right, why did the Cyclops close his school? Only had one pupil. Okay, getting straight into it today. I feel like making a bit of a ooh, 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 ooh. It's a bit of a primitive joke. Man, make fire. So we're talking about primitive functions. If you don't know what primitive means, it means it's like old school, like caveman, primal. I don't know, but it kind of makes sense. So it's a primitive function essentially means we're doing the inverse or the opposite of differentiation, okay, antiderivatives. And essentially it's finding a function before we differentiated it, which is kind of going back before, which is why it's a whole thing of called, it's called primitive. That's why we haven't evolved yet. We haven't differentiated yet. Okay. And it's kind of like an intro to integration, which is what we'll be doing very, very soon. Um, but we're just going to highlight the idea. Now, if you take a look at this, does it make sense that if we had these three functions, x squared or x squared plus 1 or x squared minus 1, if we differentiate these, all of these will actually give me a derivative of 2x. Okay, x squared derives to 2x, x squared plus 1 derives to 2x, x squared minus 1 also derives to 2x because all your constants kind of disappear. But this is where the primitive, there's a bit of an issue. If I was to go backwards, I know that the primitive of 2x could have been any one of these. I know there would be an x squared, but I don't know what the plus or minus term should be. Okay, so this is where we kind of run into this idea here. So for finding primitives, if dy dx equals to, yeah, this is just the fancy formula. Essentially what happens is you add 1 to the power and then you divide by the new power. And here's the important part I need you to remember. Every time you find a primitive or you anti-derive, you're going to need this thing called a plus c. Okay, plus c means it's just a constant. It could be anything. And until we can figure it out, we're going to leave it there and almost leave it as a placeholder that, look, there was something there. Could have been something. Okay, now just to kind of show you that it's kind of like the opposite, when you differentiate, what's the rule for differentiation? Well, I normally say it like this. The power at the top comes down, and then you minus 1 from the power. And if we do the opposite, the anti-differentiate or anti-derivative, I probably should have wrote anti-derivative. What you're essentially doing, if you look here, is what am I doing to the power? Well, I'm adding 1 to the power, and then I'm dividing by whatever that new power is, which is very, very opposite to what we've got here. Instead of the power coming down, let's put it this way. We start by adding 1 to the power is because before we would actually minus 1 from the power. And normally in differentiation, your power comes down the front, which means you multiply by the original power. Here, I'm not going to multiply. I'm actually going to divide. Okay, so hopefully that provides a little bit of understanding. Okay, so let's just smash through a couple of these. Okay, find the primitive. Let's do this. So that means x to the 2. I'm going to add 1 to the power, and then I'm going to divide by that new power. And then same thing. Here, I'm going to go 2. It's just a constant, but then I've got, or like just what we call a scalar, or just a number in front of the x. Now, technically that was a 1. So now I'm adding 1 to the power, and I divide by that new power. Okay, now cleaning things up a little bit, I can just say this is x cubed on 3 plus x squared. Okay, same thing. Let's keep going for question B. Again, I'm only looking at the x. I add 1 to the power of x, so x to the 2 becomes x to the 3, divide by the new power. Same thing here, that x now becomes x squared because I added 1 to the power, and now it's still over, so I still have a 3, but then I'm also timesing it by 2. Okay, now if you're a little bit confused on why I did that, let me just quickly make sense of it. Technically, x over 3 is the same as a third x. Okay, so it's kind of like saying a third times x squared over 2. Okay, which is why they multiply. And then I've got the plus, instead of plus 1, when I do the primitive of a 1, it actually now becomes x, which kind of makes sense because when I derive an x, I get 1. Okay, so cleaning this up, I get 4x cubed on 3, and then I get plus x squared over 3 times 2, which is 6, plus x. All right, let's work with some, what happens when we kind of have some powers now. If we've got some powers, it's going to work very, very similar. Now, it's kind of like the opposite of the chain rule. So again, work with me. That bracket is going to remain the same. I'm going to add 1 to the power. I'm going to divide by the new power. And then instead of multiplying by the derivative of the bracket, I'm going to multiply it on the bottom, which essentially means I'm going to divide it. Okay. So I times it on the bottom, not up the top, not there. Okay. And so with that, we now have x minus 2 to the power of 5 and 5, and that there would be your primitive. Okay, same for this one here. I'm going to rewrite this first as 4x minus 3. And because it's 1 over, I know it's just a negative indice. Okay, so following the rule, let's add 1 to the power. So it becomes 4x minus 3. And that new power now becomes minus 4 plus 1, now becomes minus 3. And what I do now is I divide by that new power. And then I also need to multiply, or in essence, I'm dividing the whole thing by the derivative of my bracket, which in this case is 4. So here, this just becomes negative 4x minus 3 to the power of negative 3 all over 12. I've just moved the negative up to the top. No worries, no problems there. Now, the last thing is sometimes they will give you enough information to find what that plus c is. Now, note that I did exactly what I told you not to do. All of these, and let this be a lesson. Great teaching opportunity here. Okay, all of these needed a plus c. Okay, so all of these ones up here needed a constant. Okay, very easy to forget, but unfortunately, if you do forget, you'll lose a mark. Okay, so thank God I remembered. I need you guys to work hard to make sure you remember. Okay, every time you anti-derive, you need a plus c. Okay, hammer that in. All right, finding the constant. Sometimes they give you enough information for it. So we're going to see how we go. Now, they've said something like find y if y dash equals to 8x cubed, take away 6x squared plus 5, and it goes to the point 0, 4. So they've given us some extra information here. I'm just going to make a quick little note. That's an x value, that's a y value. Okay. Now, first things first, that y dash there, I'm going to work with that. If y dash equals to that, then I'm going to integrate that, I'm going to find the primitive. And let's do that. So 8x push 1 to the power, or add 1 to the power. So now it's x to the 4 divided by the new power. Minus 6x instead of squared, it now becomes cubed. And I'm going to divide by that new power, which is 3. And then it's going to be plus 5. Instead of plus 5, it'll now be plus 5x. Okay, now I'm not going to forget this time. There's an unknown. There's a plus c. Okay, now to find this plus c, I'm actually going to use this point that they've given us. And essentially what they're saying is when x equals to 0, y equals to 4. So let's check it out. Let's see if we can sub it in now. So that means y equals to 4 when x equals to 0. Now, if you are a good math whiz, you'll notice that all these terms with x's that now get multiplied by 0 turn into 0. So you'll see here that 4 equals to 0 minus 0 plus 0 plus c. And so you can see here that c equals to 4. And so now my original equation, I know exactly what it is. I now know that y equals to 8x4 on 4 minus 6x cubed on 3 plus 5x. And instead of plus c, I now know that c is 4. Okay, now just again, I probably want to simplify things a little bit. 8 on 4 is just 2. 6 on 3 is also 2. And then 5x, and then plus 4. And I'm happy, more than happy, for you to leave that as your y. Okay, hope that helps, and I'll catch you guys later. Have fun and be good.